With a droid, users can borrow precision and accuracy from an industrial robot during open-ended fabrication tasks. Our system consists of the robot, a custom force torque sensor, the desired tool, and a projection augmented reality display. Here, we show the readings from our force torque sensor, which are used to compute motions for the robot. Inspired by workshop jigs, this system can selectively constrain the user's motions depending on the task through software. To demonstrate a range of applications, we showcase 4 tools that can be used with the droid. To use a hand drill with our system, the user selects that option through the graphical user interface and mounts the tool to the robot. After the drill is loaded, the AR system projects crosshairs onto the table to show where the drill is pointing. When the drill nears one of the virtual grids, it will physically snap to the grid, like a haptic controller. When adjusting the orientation of the drill, the AR view visualizes the current heading and elevation. For precise drilling, the user presses the latching button to constrain the drill along the current axis of the drill bit. Here, the user is working with a measurement probe. When the tip of the probe contacts an object, the robot automatically retracts the probe to a safe position. The probe tool can be used to locate specific types of geometries, in this example, the edge of a workpiece. The probe location is recorded by the system and is shown by the projection augmented reality display. For the track saw, the robot guides an intermediate tool, the track. The stock material is mounted to the workbench using double-sided tape. The AR view projects where the cut will occur relative to the track. Before cutting, the user presses the lock button on the ruler. The cut can occur when the ruler is locked on the surface of the workpiece. After the cut has been made, the AR view displays the distance between the last cut and the current position. The user can also navigate the history of previous cuts like a lightweight CAD model. Camera rigs, such as cranes and sliders, are also mechanisms which selectively constrain the motion of a tool. To define a virtual slider, the user first moves the camera to a desired start position and sets that position using the graphical user interface. The projection augmented reality view displays the X and Y positions of the configured start location, as well as the current location of the camera. After setting the end position in the same way, the rig is ready for use. All of the user's motions are constrained along the user-defined slider. Please see our paper for more details.